In this problem, we have a 4-pound ball B that is traveling along in a circle on this horizontal table. And initially, it has a distance of 3 feet from the center. Let's call this point O. And it has speed that is tangent to its path of 6 feet per second. And then there's a cord on the ball that is pulling it to be closer and closer to the center. During this process, the ball is still circling in this fashion. And we need to determine how much time is required for this ball to reach a total speed of 12 feet per second if this cord is being pulled with a constant speed of 2 feet per second. And we also need to determine how far the ball will be from the hole when that happens. We can neglect the friction and the size of the ball. In this problem, if we do a quick force analysis of the ball, we will know that it's subjected to the weight force and the normal force, which cancel each other out at any time. Therefore, the net force on the ball will be a tension force in the cable. But this force is always passing through point O. So the line of action of this tension force always passes through point O. Therefore, this force right here will not cause any angular impulse about point O. So as a result, we have these two forces, they cancel each other out. This force that would never create angular impulse about point O. Therefore, we can solve this problem using the conservation of angular momentum about point O, which means that we will have HO1 equals to HO2, and initially the angular momentum of about point O equals to mv1 times the moment arm will be r1, and then finally that will be mv2, but only the component that is always tangent to the path, in this case is actually our transverse component times r2. Okay, so what we do know is we know m, that is 4 over, so in this case actually the 2m can be cancelled out from the equation. v1 is 6 feet, r1 is 3 feet. So on the right hand side we have v2 theta that is not known, and r2 is also an unknown. However, we know that at state 2 the total speed will be 12 feet per second. And this total speed will have two components. One is the theta component that is always perpendicular to this line right here, and the other one will be the r component, and that is a constant 2 feet per second. Therefore, because of that, v2 theta can be determined as the total final speed 12 squared minus vr squared, which equals to 12 squared minus 2 squared, and that equals to 11.83 foot per second. So if we substitute that into this equation, we can solve for r2, and r2 equals to 1.52 foot. Now, we actually solved for the second half of the problem first. And then going back to the first half, it asks how much time is required for that to happen. Remember, once again, this is a constant speed of 2 feet per second pulling on the cord. So initially, R1 is 3 feet, and the final state, R2, is only 1.52 feet. So from there, we can use the basic kinematic analysis. So we will have delta R equals to 3 feet minus 1.52 feet, and that equals to VR times T, which is 2 times T. Therefore, from there, we can solve for T to be 3 minus 1.52 divided by 2. And that is 0.739 in the unit of second.